Saša, but I don't remember the name of the word. With Saša from graph illustrations in the contents of natural science in regular textbooks and textbooks for students with special educational needs in the Republic of Serbia. I was talking to them, so about 10-12 minutes of presentation, and we will open for just one question. I think I can count on your comprehension because of the time. Yeah, he sent us. Yeah, because we have time to go. Thank you for your attention. So, your speech.
Thank you. Thank you, Solange. I'm Saša. I'm not the first time of this conference. It's second time in a live. One was online. So, I'm coming from Serbia as my colleagues, and to come to Lithuania, you need to change 4 ways of ride, to change 3 cities, 2 countries to come to Šiauliai via Vienna. So Serbia is a Balkan country in Balkan region. Nowadays it's famous for Novak Djokovic and for Nikola Jokic, but we are on science conference. We are also known for 2 very famous inventors, Nikola Tesla and Mihailo Pupin. Our capital city is Belgrade. This is this green dot. Novi Sad is part of municipality of Vojvodina. We have second municipality Kosovo. We'll skip politics. This is our faculty in Novi Sad, and this are my colleagues with me who works with me on this paper. So, short introductions. I will talk about illustrations in textbooks, and they are important source of knowledge for our students. And they are not in textbooks to fulfill number of pages. It's good to remember that one picture is 1,000 words. And to classify illustrations, we use 2 methods. One was developed by Dimopoulos et al. And he classified illustration in the textbooks according to the type as realistic, conventional, hybrid, and hybrid illustration. Realistic illustration contain pictures from everyday, something from history. Conventional contain, beside that, some numbers, molecular structure, and hybrid illustration are combination of previous 2. And degree of abstraction is calculated as the average value of geometric shape of illustration, and alphanumeric tasks are represented in illustration. Color palette, if that picture is monochromatic or contain number of colors. And contextualization, it's based on color of background. Is it same as page in the book, or it's different? And you get value from 1 to 3. 1, if value of abstractness is 1, that picture is low in abstractness, and 3 is high. And also, we used method developed by Sousa and Porto, and they classified illustration in textbook into 9 subcategories: laboratory equipment and experiments, industrial plants, production, graph and diagrams, models, analogies, illustrations from everyday life, mineral plants, animal samples, to history of science and concept of natural sciences. So the main aim of our research was to qualify illustration according to the content, as well as difference in graphic illustration in context of natural science. And for that we used 2 textbooks. We wanted to make comparison between textbook for regular children that go in everyday school and to children with special needs. They go to special school, they have some disorders, they don't hear good enough, so they don't those deaf children not included in regular system of education. And only textbook that we could found that was written for children with special need was a textbook for physics. And believe me, it's old textbook. Textbook, you will see it was written 28 years ago and nothing was done in that field. So we used two previous mentioned methods by Dimopoulos and Sousa and Porto, and results of our research will be analyzed in formal relative representation of illustrations, illustration according to type of illustration and degree of abstraction of those illustrations. I showed on that slide some examples from textbooks that we used and some topics that were in those textbooks: density, heat transfer, and static electricity. As I mentioned before, it's easy to see that illustration in special textbooks are old. It's from yellow pages during the scanning, and these in regular textbooks are more modern because these textbooks is really new. So we search for topics that can be compared in our analysis. We found only 4 of them that can be found in regular and special textbooks. Those are Introduction to Physics, Physical Quantities, Force, and Motion. And to calculate relative representation, you need to have one topics need to have at least one, according to Dimopoulos et al., need to have 1,000 words. It's easy to notice that in special textbooks, number of words is less. So we adopt that method and we calculate number of illustration that all those topics would have if they have 1,000 words. So here are our results. On that graph, we can see index of relative representation of illustration in selected physics textbooks. And it's easy to notice these blue lines are from special textbooks that I'm going to call in the future, and yellow one is from regular books. And index is much higher in all topics in special textbooks, comparing to regular, except in topics of motion. After that illustration, we analyzed percentage of illustrations by type, and in the special textbook, the most represented are realistic illustration. It's expected because those children have a limited cognitive capacity, they have some kind of disorder, they have small books, and for them is the easiest way to connect everyday life is with photos from everyday life, while in regular textbooks percentage is quite the same. We could see that conventional illustrations are the most represented, but it's not so statistically different. In realistic illustration, the most elements represented in special textbooks is laboratory equipment and experiments, and something illustrations from industrial production and plants. And in regular are pictures from everyday life, and also it's quite interesting history of physics, but it's smaller present. About conventional, that illustration contain some elements, letters or numbers, and they are connected with everyday life pictures and graph and diagrams. And hybrid illustration in special textbooks contains elements of everyday life, graph and diagrams. In quite opposite in regular is graph and diagrams the most represented between hybrid illustration. According to degree of abstraction of illustration, we got quite interesting results that the realistic, conventional, and hybrid illustration in regular book are low abstractness and what was surprising, high and medium degree of abstraction of illustration in special textbooks. We didn't know what was happening. Maybe something with this method, but we need to make further inspection of those results. So to conclude, what I was to say, that greater number of illustration in the textbook for children with special educational needs is represented. It's quite normal, I mentioned that. And these books contain much larger number of images compared to the number of words in the regular textbooks. And that textbooks for children with special educational needs relies on pictures from everyday life rather than on models, historical facts, and etc. It's quite important to explain laws of physics through realistic examples for students. We know that it's hard for children with special needs because they don't have they don't know knowledge, and it's hard, but we need to stay focused and try to correct that and explain to them. And future potential survey among teachers about the quality of graphics illustration and quality of textbook in Serbia will be a way of our future research. And that's all.
Okay, thank you. We have time for one question.
Saša, what means exactly in realistic picture the level of abstraction? Sorry. Yeah, I know it when I prepare some picture, but some order of abstraction is from real things through models, through pictures, to symbols. It is traditional difference. Now I'm thinking about your classification, realistic picture. That means lower realistic, middle realistic.
Yeah, it's calculated, as I mentioned, there is a formula. Calculating number of colors, number of marks, are they both represented, for example, numbers, or how many colors is represented, background of color, and you get same value between 1 and 3. And if it's close to 1, it's low, and if it's close to 3, it's high abstract.
Okay, thank you. Thank you, Saša. And now Marcella Seika Shimada with me, students' perception of an inquiry-based metavisual activity about concepts of chemical kinetics. Marcella, it's your speech.
Hello everyone, my name is Marcella. I'm a student at master's student degree supervised by Solange. I'm a student from the Federal University of ABC. I'm a Brazilian. The most people get surprised with this information, but in Brazil we have a huge community, Japanese community, and in addition, Brazil has a lot of types of people, so our group, Giovanni, Carla, and so I think represents our country, the diversity. So, for a deepened understanding chemistry, the students must access and transition from the 3 levels of chemistry representation: macro, submicro, and symbolic levels. Metavisualization can be a strategy for improving students' understanding of the use of these representations and modeling experience. So, and in addition, link these concepts with real-world phenomena to pique students. We need to do this, pique students' interest. So inquiry-based activities can be helping in this sense. So we use these concepts and we develop an activity who call it inquiry-based metavisual activity, IBMA in short. But limitations that students face when they are developing in-depth models in chemistry must be considered. So, when we assessing students' perceptions about this activity, we can see the difficulties, evaluate the activities of the strategy, and make some adjustments to provide a more positive learning experience for them. So here the question of my research is to understand how undergraduate students from different courses perceive their participation in an IBMA activity. So this is the steps of my research. This is a qualitative and case study. Was developed in a public Brazilian university in a subject called Chemistry Teaching Practice. In this course, 4 students was enrolled, but in the day of the activity, 1 was absent, I think. So the participants of these students was 3. 2 of them were chemistry education students, and 1 of them was engineering student. I will show you after, and I do an interview with them. We select 2 questions for this research. Here is the big picture of our activity. There are 2 main phases. The first one was problem situation with reaction metallic iron with sulfuric acid. They following these steps to get the solution for this problematic. And the first step, they elaborated and comparison of the representations. So they made a chemical equation, a model in the submicro level before doing in the final chemistry reaction of this problem. And in the steps, for example, they do a chemical equation. The students in a group, they made a chemical equation. So after that, the teacher of the classes show them a right chemical equation. So they compare what they made compared to what the teacher representation they made. There is we call a metavisual stage. So they compare the similarities and difference between the models. We do after in each of the steps. And here is an example for one model we'll use in this activity in ambient temperature, in high temperature. So this is the 2 questions. We select 2 of the students to see main difficulties encountered in the development of IBMA, the students' difficulties, and it helped them to reconstruct the concepts if anything changed for them in chemistry terms. So, the chemistry education students had similar answers. The difficulties related by them was in the elaboration step. Made the chemical equation and the models in the submicro level, but they related the submicro level in this activity assisted their composition of chemical reactant. So this submicro level allowed them to understand what was being observed in the experiment and related to the chemical equation. In this sense, these students can relate and transition between the three levels. So this activity for these students was beneficial to enhancing a students' comprehension of chemical reactions and their ability to connect different representation levels. But it's important to highlight their prior knowledge of chemistry, modeling, experience, and the motivation to deepen their understanding play crucial roles in their actual learning during the IBMA. On the other hand, the engineering students have difficulties related to the micro level, so he related difficult in see the changes in the chemical reaction, and about learning chemistry, he understood the result of the phenomenon, but he would not be able to replicate the same concepts in the other situations. It may indicate that submicro level was not very clear for him. In the sense, the explanatory models, the submicro level, probably have a high intrinsic burden, so he selected the aspects that are most familiar to him when we are talking in an interview, such as visual phenomena at micro level. Unlike his group mates, the chemistry students, he did not participate in other chemistry classes in the university and modeling activities. So he, in the sense, his modeling is less than his classmate. I think. I don't know if I say right now. This suggests that students who are less proficient in this representation should be engaged in a step-by-step process to be enabled them to understand more complex models. So, for the conclusion, we in this research we find the activities and challenges of an IBMA approach. This is a limited study by the context, but the results provide exploratory evidence for the use of metavisual strategies and chemical representation in classroom, considering the students' level of familiarity with chemistry, models, and experimental practices. So, the representations are not self-exploratory, requiring teacher intervention, especially with the students who have a little familiarity with the model as engineering students. And it's important to consider the student background knowledge for a more active. Right? These are my preferences, and Atio.
Thank you, Marcella, on time. One question, please. Yeah, Angela, please.
I just wanted to ask a methodological question. If you had to do it again, how differently would you do it?
What?
A methodological question. So the methods that you're using, if you had to do it again, how differently would you do it and why?
Maybe I do. In the sense, maybe I will to raise the prior knowledge from the students before the activity. In this activity, we expect the students collaborating with them to explain these models. The chemistry students help the engineering students. But in this case, the students don't have a good relationship, so did not work well. But for this activity, I think we must beat this contest before the experience, the prior knowledge, their relationships, and things like that.
This was something we want to look at, because there were 3 students and one of them were not connected to the others. They are fighting all the time. No, you don't know that. No, you don't. It was kind of difficult. So we are going to look at this. to understand better. Thank you, Marcella.
Thank you, Marcella.
And now, Agnes, the application of interactive learning tasks made by using digital hybrid illustrations in the topic hydrocarbons in 8th grade organic chemistry classes.
You didn't have to read it. Anyway, let me introduce myself. I'm Ivana Z from the University of Novi Sad. I'm a PhD student. This was my last year, last semester. And I want to thank to my professors Tamara Rončević and Saša Horvat for mentoring and for supporting of my work. So today I would like to talk about the application of interactive learning tasks made by using digital hybrid illustrations in the topic hydrocarbons in 8th grade organic chemistry classes. This is my first time here in Lithuania. It's a very nice country and very nice people. Yeah. And I'm pretty sure this is my first time in life to present in English, so it will be interesting. First of all, I would like to talk about the hybrid illustrations. I'm lucky because my professor was talking about that in his presentation, but anyway, I will talk about that. And of course, I would like to talk about what was the aim of our study. Then I would like to talk a little bit about the general background of our study, the sample, the procedures, and the instruments, of course. And then I would like to make a little discussion from the perspective of the task with and, of course, without illustrations. And, of course, in the end, conclusion and implications. So first of all, we know, it's not just in Serbia, but according to many studies, students learn most effectively when they see what they learn, so through the visual perception. And of course, one of these methods we can use in the education is the illustrative graphical method. So when we use something to show something to present in visual formats. One of those applications can be by Dimopoulos and others, by the hybrid illustrations. This is the type. This is one of the type of the illustrations. This is a combination of abstract elements. So, for example, in this case, chemical symbols with realistic ones, so with realistic pictures from everyday life. In this study, it was examined the possibilities of applying those the graphical illustrative method, teaching method, in a form of digital hybrid illustrations, so in the form of interactive learning tasks. As you can see on this little video, it was a memory game, so the students had to match the molecular models with the everyday use of the hydrocarbons. The study focuses on the lessons of the units. First of all, a review of saturated hydrocarbons and general properties of hydrocarbons, and the second one was the systematization of materials from hydrocarbons. Our goal was to analyze the differences in students' performances of the two groups. One was the experimental and one was the control group, observing the hydrocarbons teaching topic in the 8th grade organic chemistry classes. And according to this goal, we made 3 research questions. First of all, are there a statistically significant difference in the students' overall performances on the knowledge test between the two groups? Are there statistically significant difference in the students' performances in the task with illustration between the two groups? And of course, in the end, are there statistically significant difference in students' performances and the test without illustrations, in the tasks without illustrations between the experimental and the control group. A little bit about methodology. We did an initial testing in January 2023 when we just analyzed the prior knowledge of students on inorganic chemistry. I have to highlight that in Serbian education system of chemistry, the inorganic chemistry is right before the organic chemistry topic. So the students were divided into experimental and control group according to the test results in initial testing. It was around 200 students from eighth grade classes from 2 primary schools from Novi Sad in the Republic of Serbia, and of course the research was done in Serbian language. So first of all we did the initial testing, then so the experimental and the control group students as well, processing of division of hydrocarbons and processing of alkanes with their teacher in school. So it was a traditional method, nothing special. Then I went to the school, to the experimental groups, and the first review and practice lesson was done. We were working through the Moodle platform. Then they were processing the alkanes, the alkenes, the nomenclature, the chemical properties of hydrocarbons, crude oil, and in the end, the polymers in the experimental and the control group as well with their teacher. And then I went again to the school to a review and practice lesson about the processing of alkenes, etc. And we were working on the Moodle platform in the experimental groups. And in the end of all these processes, we did a knowledge test on hydrocarbons, uniform testing in the experimental and in the control group as well. A little bit about the platform, this Moodle platform. So the students had their own accounts. Who is working on Moodle knows that they can have their own account. It's available from their cell phones. It was available from their cell phones, so they were working through their cell phones. And it was working on interactive tasks. So I just projected the task from my phone. I projected my own phone, my own cell phone to the blackboard, and we were working together. So after the teaching and the learning process, as I said, within the topic of hydrocarbons, both the experimental and the control group underwent uniform testing. Students took a test, about 15 tasks. There was a multiple choice question, fill in the blank question, matching question, for example. And the test included a total of 9 tasks with illustrations and 6 tasks without illustrations. The maximum possible score was around 28 points, and yes, there was a statistically significant difference in favor of the experimental group. If we are looking at the wall test results, the experimental group students' average performance on the wall test was around 46%, while the control group average performance was around 39%. Let's see from the perspective with illustrations, tasks with illustrations. There was no statistically significant difference in performance between the experimental and the control group, but there was some cases in some tasks when there was a larger difference between the experimental and the control group. For example, at the task number 14, there was a task about, we tried to find out if they know which is the fraction of crude oil, which is the fraction of crude oil what is boiling at 170 degrees Celsius and can be used as a source of energy, as a fuel for aircrafts. Of course, the right answer was kerosene. In the experimental group, there was around 82% of students who gave the right answer, and in the control group, it was only 66%. It can be explained by the fact that when I went to the school and we did the review and practice lessons, we were working with a hybrid illustration, what you can see on the video. So the students had to place the fractions on the interactive hybrid illustration, so they were matching the everyday use and the boiling point with the name of the fraction. What about the tasks without illustrations? There was a statistically significant difference in the performance between the groups. And I have to say that the highest difference in the performances was at these tasks, when the experimental group students just outperformed the control group students. For example, at the task number 4, where we try to make a task with division of hydrocarbons and the structure of the outcome, and the maximum point at this task was 5, and in the experimental groups the average was 2.3, and in the control group it was average 0.9 points. So it was a big difference, a huge difference, and it can be explained by the fact that when I went to school, we did a task when the students had to match the detailed division of hydrocarbons in a diagram, and they were working with an interactive hybrid illustration. So we can say, as our experience says, that using digital interactive hybrid illustrations, the teaching process itself can make learning chemistry playful and motivating. I saw that my students they were improved by the method, by the new method, by using their phone for learning, and not just for Instagram or Snapchat or anything like that, but for learning. They were just improved. As previous research says, hybrid illustration can be useful in learning and teaching of chemistry. And the overall test results show that there's a statistically significant difference in the performance between the experimental and the control group students. Of course, in slight favor for the experimental groups. And I think it requires the continuation of the experimental teaching with the Moodle platform. And of course, the next part of the research, because it continues, the next part of research is to analyze the data given by the topic oxygen-containing organic compounds. And of course, we would like to applicate this method in other lessons, for example, in presentation or in evaluation lessons. So maybe it will be the future plan. Thank you for your attention. And if you want to see the platform, you can scan the QR code.
Thank you for your presentation, Magnus. One question. Giovanni.
Hi, thanks for your presentation. I would like to ask you about your methodology. Why did you choose to use control group and experimental group? I ask him this because, especially in Brazil, we don't used to see this kind of methodology. Why did you choose? Is it common in your country?
Thank you for your question. I think it was the statistically, it was just based on the statistical analysis of the initial testing. So we analyzed the initial tests, and I think it wasn't, I'm sure about that it wasn't a big difference between the genders, between the number of students, between the two groups. I don't know if I gave the answer for your question, but
maybe this question is for us, so more and more critics for experimental methods in pedagogical research. But maybe it is your meritum of your question.
Of course, yes. I would like to add
But
that.
in my young time, it was not possible to think about pedagogical research without pedagogical experiment. But now is some bigger criticism for you. But maybe we can ask you, it was the same teacher in both groups?
you mean in the experimental and the control?
Yeah.
No.
No. Yes, it is next parameter, which one is little bit influencing for the results. And next. But okay, it is nothing against you. But it is more and more about paradigmas of pedagogical research. But be careful, but in my young time was not acceptable, for example, quasi-experiment. It means nature experiment, only one group. But now, many studies, they make some meta-research about conceptual understanding, influencing of technologies. But many now impacted publications are based on quasi-experiment. Many times we are resigning from the traditional setting of experiment for it. But you can think about for the next your development, for the next researches about this. Not only classical traditional experiment is right way. I think it was better to your question. Thank you.
I
We
have,
can discuss.
no, I have to add that
You can have the different.
no, I'm not sure if it's important to say, but it wasn't the same teacher in the experimental and in the control. No, it wasn't the same, but in the experimental groups, it was 4 classes, four classes around 80, 19 students.
In the same school?
Yeah, in the same school. So...
Did they have the same teacher?
Yeah. So same school, same teacher.
Oh, okay.
So...
Experimental control was different school and different...
Only one teacher, yeah.
But you can explain it in limits. You can write limits of my...
I was thinking about that, yeah.
I hope so.
The limits.
I hope so.
Okay, thank you. Thank you so much. Well, the next presentation, Tamara. Secondary school students' perception of biochemistry concepts by using word association test.
Thank you very much, Solange, for the introduction. My name is Tamara Rončević. I come from Faculty of Sciences, University of Novi Sad, the same university as Saša A. And today I would like to talk about secondary school students' perception of biochemistry concepts by using word association test. At the beginning, I would like to present the content of my study. Firstly, I will provide some introduction to my study. Then I will define the research aim and research questions. After that, I will provide some methodology with participant, instrument, and procedure. The results of this study would be divided in 3 different parts with counting response words, calculation of relatedness coefficient, and presenting the relatedness network. And at the end of my presentation, I will provide some final conclusion and future work. Excuse me. So the introduction of our study. So I would like to start with the all-known content that chemistry is abstract subject and the complex subject. And one of the most important aims of chemistry education is to provide conceptual understanding for our students. And it is not an easy task, we know that, but in order to complete this aim, it is very important to provide proper interconnections between the key concepts within our students' mental models or knowledge structures. And to obtain this aim, in the literature there is several instruments that could be used, and one of them is, of course, word association test. The research aim and the research question is provided on this slide. Firstly, the research aim was to analyze the secondary school students' knowledge structures about biochemistry concepts within the international baccalaureate diploma program students. And in order to do that, we used word association test. I know that this instrument is not new in the chemistry education, also in science education, but it is very important when the interconnectedness of the key concepts is in the picture. And because of that, this instrument is in use now and it is improving. And my aim was to contribute in this field and to provide some new insights into this instrument. So according to the research aim, I defined 3 research questions. First, how do IB students shape the concept of carbohydrates in their minds? The second research question, which terms evoke the concepts of carbohydrates to them? And the third, most important research question, on which level is the connectedness of carbohydrates keywords within IB chemistry students' knowledge structure? So, and the next slide, I will provide some methodology. So, as I said, the participants of our study were secondary school students from one gymnasium in Novi Sad, Republic of Serbia. But I would like to highlight that they were not the regular gymnasium students. In this particular study, our participants were international baccalaureate diploma program students, and the IB program is well known as a rigorous one, and the students within the gymnasium, third year and fourth year, are enrolled in this particular program. And in our study, I only included the fourth year students in my study, so I have a really small research sample, as you can see. Also, I would like to say that international baccalaureate diploma program in our country is something new. So we are at the beginning of the research within these participants, and also because of that, I believe that I have what to say about these participants and to make also contribution within the research sample. So also for the association test, we know that it is one kind of open-ended test, and that the main aim of this research instrument is to link or to provide some links within students' knowledge structure about some particular topic. And within my study, I choose one research topic, it's carbohydrates from biochemistry. And IB students in our country has the opportunity to choose one of 4 options. And in our case, this was, for example, biochemistry. And the other 3 options were, for example, medical chemistry or thermochemistry or energetics, but they were decided to learn more about biochemistry. Also, it is important to highlight that IB students are divided in 2 levels. There is standard level students and higher level students. And it is also important to highlight that it is their choice. So me as a teacher was not someone that divided them, you will be the higher level student and you will be the standard level student. It is their decision to be on these 2 parts of learning. So on the table 1, you can see biochemistry concepts that were enrolled in our study, and you can see that some of these concepts were common for both levels. For example, introduction to biochemistry, or proteins and enzymes, lipids, carbohydrates, vitamins, and so on. But we have several additional topics that were only for the higher level students. For example, inhibitors and amino acids and proteins buffer in solution, or biological pigments and stereochemistry. And also it is important to highlight that this study was conducted in this school year in January. So this is the look of word association test. It was presented to our students in the form of booklet, and the booklet has 8 pages, and each keyword was presented on the separate page. And our students was instructed that the time to solve word association test is limited. So they had 60 seconds per one stimulus word in order to provide enough number of response words to each of 8 stimulus words. So it was the first part of the one task in the booklet, and the second task was to write the sentences that should include the proper information about the stimulus words and also about the response words. And you can see one example of the response of my students, and also it is important to highlight that the stimulus words that we have used in our instruments were, for example, monosaccharides, glucose, cell respiration, fructose, disaccharides, glycosidic bond, polysaccharides, and starch. And now I will present the research results. As I said at the beginning, we have 3 parts, separate parts of the research results. Firstly, it was the counting of different response words for each of 8 stimulus words. After that, we calculated the relatedness coefficient. I will present the formula. And after that, we presented the relatedness networks. for the group of students. So at the beginning, we started to count the different response words for the 8 stimulus words. And you can say that for some stimulus words, for example, as monosaccharides or glucose, our students were able to provide enough number of diverse response words. And on the other hand, for stimulus words like polysaccharides or fructose, they were not able to provide enough number of different response words. And because of that first results, our first hypothesis was that, for example, for the stimulus words that they were not able to provide enough number of response words, maybe this was the keywords that were not integrated in their mental models in the proper manner, but it was just the first hypothesis. After that, we calculated the relatedness coefficient. I would like to say that firstly, we look for the original formula proposed by Garskov and Houston's relatedness coefficient, and you can look how this formula is in original version. However, we made some proper changes in this original formula, because in original formula, the authors use the ranks within the stimulus word that are compared in this formula. But in our version, we did not use the ranks, we used the real frequencies for 2 stimulus words that were analyzed. And because of this change, we were able to provide analysis of the group of students and not for individual students, and it was done in the original version. And for example, when we calculated the relatedness coefficient between first 2 stimulus words, for example, monosaccharides and glucose, we calculated the relatedness coefficient that was higher than 0.350, and we have concluded that there is a really high relatedness between these 2 stimulus words in our students' mental models. After that, we have done the same thing for all possible pairs of stimulus words, and all calculated relatedness coefficient are presented in table 3 within this presentation. After that, we use so-called cutoff point in order to prepare and to present so-called relatedness networks. And the first cutoff point was for the calculated relatedness coefficient that was higher than 0.350. And as you can see from the figure 2, 7 from 8 stimulus words were presented in this after the first cutoff point. And for us, it was very important one results from this relatedness network. As you can see, we have polysaccharides integrated in this relatedness network. And polysaccharides was the key concept that had the highest number of these high associative strength with the other stimulus words. But our first hypothesis, when we started to analyze our data, was that for the polysaccharides, our students were not able to provide enough number of different response words. And we believe that this key concept cannot be integrated properly in their mental models. And our hypothesis was wrong, according to results of these relatedness networks. After that, we made another cutoff point. And with medium relative strength between the stimulus words. Also, one stimulus word, cellular respiration, did not appear within this relatedness network, but we received another 2 association between starch and monosaccharides and fructose and starch, and we believe that starch is a key concept that would not provide some strong strength of relations with other stimulus words, but maybe with some medium, or even, as you can see here, a low strength of relations with other stimulus words. So I could say that the main conclusion of this study was that the word association test could be successfully applied in order to analyze secondary school students' knowledge structure about some topic that we choose. And also, one of the main results of this study also is for me as a teacher of these students that, for example, one keyword, and it was cellular respiration, remained totally isolated from the other stimulus words. These stimulus words did not appear on any of the networks that we have presented. And it was really valuable feedback to me as a teacher that I should revise this concept with my students again in some future. Also, in the future, I would like to analyze the second part of this instrument, my student sentences that they write about response forms and stimulus words, and also to integrate them as possible misconceptions or some relevant scientific knowledge. And also, I believe that one of the main contributions of this study is this change that we have made in the procedure of calculating relatedness coefficient in order to provide insight into a group of students and not as individuals. And also, at the end, I would like to thank my research team for their contribution for this study, and also some financial support, and also my students who participate in this research, and you for your attention.
Thank you, Tamara. One quick question, please. No question? Yeah. You.
What about experiment? No, I
What about your experiment?
What experiment?
Provide qualitative question. Because before it was discussion about experiment. What is your opinion?
About my experiment, I don't...
Which experiment? Martin,
for the Agnes, you mean, of course.
Yeah.
In our Republic of Serbia, it is traditional that the PhD thesis is written that if you have some new, I can say, teaching method or teaching instrument, you should use this type of research. So you should have control group and you should have experimental group in order to compare them. Also, as Martin said, you must think of the possibilities and variables are the different teacher impact, of course, different school impact, and we'll use all these variables when Agnes will start to write her thesis, but this is something that is common in our country, and it is expected from the candidate to include in the PhD thesis.
Yeah, okay. It's not only in your country, it's common methodology, a mental approach, mental research. And I don't understand why Martin argued this issue.
No, it was not.
That's more. Okay.
But Tamara used the methodology. But my question is different. What is consideration the results? It is some confirmation that the bachelor content is right, or that each procedure is right, and you can change something after this strong connection and weak connection.
Is it about my study or Agnes study?
No.
Okay. As I said, I received really important feedback for me as a teacher. So I would like to say that ID is something different as national program in Serbia, but I like it more than our national program. And for example, the classes are really small. There is not more than 20 students in one class. And it's very important because we apply new teaching devices, new teaching methods. The students are really flexible in the classes. For example, I use, as previous letter speaker said, the flipped classroom is something that is common in this type of procedure. So I also use some different formative aspects of assessment, and word association test is one of them. And always I receive some valuable feedback as this cell restoration we might talk related with the environmental models, and I have faith because it is something that is included in their real examinations. It is not a summative assessment, it's part of formative assessment, but it's really for some additional information for me as a teacher on which I should pay attention in the future in order to prepare my students for summative assessment.
Thank you very much, but also in my mind was you presented this oriented graphs. It's very nice to confine the order. You can start here and you can finish the course.
Thank you, Martin.
Okay, thank you all. Well, the last presentation, Carla from Brazil, prior knowledge about science from drawings by a group of deaf students. Carla, Marcella, and me. It's in your hands.
Thank you. Thank you, Mr. Solange. I am Carla. It is important to say I am start to learn English 2 months ago. Yeah, okay. This is my sign in Libras that I use with deaf community in Brazil because it is common. Each two person to have a sign. I'm sorry. For example, Carla, my name in Portuguese. Sign my name in Brazilian Sign Language. Yes. For example, I'm sorry. I have 3 children, Guilherme, Gabriela, Yasmin. Gabriela is a deaf girl. And she gave me my sign, Carla. I'm a doctorate student at Federal University of ABC with Marcella Giovanni. My mentor is a Dr. Solange Locatelli. Well, this research was developed. This research was developed in partnership with Marcella and Solange. This presentation is about prior knowledge about science from drawings by a group of deaf students. Let's start talk about importance of science education. In science education, the construction of a concept can be developed from the students' prior conceptions. It is believed that science education can play an essential role in the formation of critical thinking. However, in general, it is common for students to present a stereotype view of science, often it's information obtained from TV, magazines, newspapers, textbooks, internet, among others. In the case of deaf students, the communication barrier can make it difficult for these students to discuss this information perceived by sight. So, we understand sign language is as a language modality used by the deaf community in different countries. For example, European countries sign language use based on Portuguese sign language. Lithuania, Estonia, Latvia, for example. But in Brazil, sign language is based on French. The law 10,436 of 2002 recognizes Libras as means of communication and expression for Brazilian deaf people. For example, do with me. I, you, we, Libras, learning, good morning, good afternoon, for example. Well, our research was guided by the question: what are the ideas that a group of deaf students from a bilingual municipal school have about science? The objective of this research is to verify the prior knowledge of a group of deaf students about science based on drawings. Methodology. It is important to say it is a short version of a more complete research that is in progress for doctorate degree. Well, the group formed by 5 students from the 7th grade of elementary school from a public bilingual school for only deaf students, located in São Paulo, Brazil. The students are Fernando, 12 years old, Ricardo and Rita, 13 years old, Gustavo, Marina, 14 years old. These are fictitious names because ethics. It's important to say the students had access to Libras in school. They are our children of hearing parents who don't know how to communicate in Libras. The activity had three steps. First, a conversation and elaboration of the drawings. Second, explanation in Libras of the drawings by the students. Third, closing with conversations about what the students thought of the activity. The question the students, we asked, how do we imagine science? Translating Libras, for example, translating Libras. For example, I'm gonna explain about the analysis the data, collect the data. They collect the data for the drawings and the video recounts of the students' explanation Libras about the topic. So, the analysis of the data resulted in three categories: a planetary spatial review, science mediated by the internet, and a typical drawing. A planetary spatial review, here a student's explanation in Libras, but I'm gonna explain about the category. Marina and Fernando drawings about science involved planets, the solar system, scientists. The drawings show that the students see science as something very far from their daily lives. They understand science as a complex subject only for experts. Science mediated by the internet, two students, Rita and Ricardo, asked permission to use the internet before making their drawings. The drawings without Rita and Ricardo googling science, word science. After searching internet, the drawings resulted in video images that were copied from the internet. The last category, and a typical drawing. One student, Gustavo, may not have understood the task because he do characters, video games, that he used the drawing. When he tried to communicate and talk about his drawing, his speech was not in connection with his drawing. For example, night, not drawings. For example, repeat the students Rita and Ricardo. Gustavo used gesture to communicate with indicate he is not familiar with Libras. Used gesture, no Brazilian sign language. To conclude my presentation, the data obtained in the study showed that students in general present a distance from scientific knowledge connected to everyday life. It was observed that information can influence students' conceptions of scientific nature. It was noticed that Libras is still little disseminated in a predominantly Hive society. The category seen in this research evidenced an individualistic and elitistic view of the scientific profession. It is a study in progress with some limitations. However, the data indicate the necessity to continue the research about the topic. References. Thank you.
Congratulations, your first presentation in English. Thank you, Carla.